Hello everybody. Today we are going to continue talking about transformations of a quadratic function, but today our main focus is going to be the a value. And so the a value would be the coefficient in front of your x squared. So to simplify things today, we're going to take out the h and the k, which that h is what moved our parabola from left to right. The k is what moved it up and down. And so today we're going to be focusing on that number in front. So if my function would be y equals 2x squared, how do you think this would be different from the parent function, which is y equals x squared? And remember, what we can always do is to make a little xy table here. So remember, the vertex is whenever you square a zero. So if my x is 0, then I say 0 squared is 0, 0 times 2 is 0. So I would still have the same vertex. But what if my x is 1? Well, remember, you have to do order of operations, which means you do exponents before you multiply. So 1 squared is 1, and 1 times 2 is 2. And what if my x is 2? 2 squared is 4, 4 times 2 is 8. So what is that going to look like if I put this in my graphing calculator? So I'm going to say 2x squared, and then you can see that the blue parabola, it actually got skinnier than the parent function. And that parent function where the a value was 1, so remember, if we didn't see anything in front of there, today's the first day where we're seeing a number there. When that a value was 1, that means from the vertex you go over 1 and up 1, over 2 and up 4. So notice on this blue parabola with a vertex, or with an a value of 2, from that vertex you go over 1 and up 2. So what would happen if I would say y equals 5x squared? So I'll put this in, I'll change the blue one. So 5x squared. So it's going to be even skinnier, and then from this vertex we go over 1 and up 5. So what else could happen with that a value? So what if I have an a value of, 1/2? So any predictions on what would happen if I would change my a value to 1/2? I could actually, I could do 1/2 x to the second. So this is going to make that parabola wider than the parent function. And what we say there, when it's wider like that, we say that it's a vertical shrink. And if you imagine like a rubber band, like if you vertically shrink it, it's going to kind of get shorter. When it gets, skinny, we say it's a vertical stretch. It's going to get kind of like taller and skinnier. And I wish I had a rubber band here to show you that. But anyway, back to this blue one here, which has an a value of 1/2. If you go over 1, you go up 1/2. And so you'll notice that that's where that is. So that a value is what changes, how wide or how skinny that parabola is. There's one more thing we need to talk about with that a value. What if I would make it a negative? So let's just say, a negative 1/4 x squared. So I'm going to leave the parent function in there, and I'm going to make this negative 1/4 x squared. And what kind of predictions do you guys have? Because the negative makes it flip upside down, and then the 1/4 is what makes this kind of like a wide parabola, or we say a vertical shrink. So imagining that rubber band, if I, shrink it, then it's going to kind of get wider. So again, from that vertex, you go over 1 and down 1/4. And so that's where another point is on that graph. So that's a little information about the a value, and then tomorrow we will talk about how we can graph them on our own without a graphing calculator, and try to put all of those transformations together. Thanks for watching.